In the previous online lecture, we talked about the general mechanism for ES reactions, and we were able to see that actually ES reactions involves replacing the hydrogen atom of benzene with an electrophile. So you can see in this case, what we have done, we have replaced one of the hydrogen atoms of benzene with an electrophile. So when you have benzene, like in this case, it doesn't matter which particular hydrogen atom you choose to replace. You can replace this hydrogen or any of these, so long as you only replace one hydrogen atom. Now, as you move beyond benzene, you have benzene derivatives. This is when things start to get really interesting because these substituents actually determine which particular hydrogen is supposed to be replaced, and they'll also determine the rate of reaction for ES reactions. We actually have two types of substituents that affect ES reactions. We have activating groups and also deactivating groups. In this online lecture, we'll focus on activating groups. We have three categories of activating groups: strongly activating groups, moderately activating groups, and also weakly activating groups. Let's dig deeper by looking at these three categories in details. Strongly activating groups include the amino group, which can also be in this form, the hydroxy group, and also the alkoxy group. All these groups that you see make benzene to be more reactive towards ES reactions by making it to be more nucleophilic. Let's see how this is done. To explain how strongly activating groups make benzene to be more nucleophilic, we use phenol as an example. As you can see here, the OH group has got two lone pairs of electrons, and since we have two lone pairs of electrons, the OH group can donate one pair of electrons like that, and that means that we can put the negative charge on the ortho carbon. We can also put the negative charge on the para carbon by moving the electrons in that manner, and so we can put the negative charge on the para carbon. Now, the take-home message here is that strongly activating groups make benzene to be more nucleophilic by donating a pair of electrons, and also they can put the electrophile on the ortho position and also the para position with respect to the activating groups. In case you're wondering what the ortho and para positions are, I've got you covered. So you can see here, this particular position, this carbon here is ortho with respect to this group which is here. So why? Here we can have any group. It can be an activating group or a deactivating group. So this position ortho with respect to Y. This particular position here is meta with respect to Y. Then this other position here is para with respect to Y. So because of symmetry, this position also is meta with respect to Y, including this position is also ortho with respect to Y. Now let's talk about moderately activating groups. Examples of moderately activating groups include amide and ester groups. So these are examples of moderately activating groups. Now, why are they called moderately activating groups? Let's see why this is so. To show why they are called moderately activating groups, we'll use the ester group as an example. First of all, these groups are able to donate electrons by means of resonance like the strongly activating groups. The only difference is that these particular groups can donate electrons in two competing directions. So you can see here, this particular carbonyl group here, this carbonyl group here is pulling the electrons from this oxygen, which has got two lone pairs of electrons. So this particular oxygen can donate electrons in this particular direction. It can also donate electrons in that other direction it can donate electrons to the benzene ring. So because of the fact that this particular group is donating electrons in two competing directions, it makes it to be less effective as compared to the strongly activating groups, which only donate electrons in one direction. So it's because of that fact that these are called moderately activating groups. Let's talk about the third category. Examples of weakly activating groups include the alkyl group, the phenyl group, and also the vinyl group. Now, these groups cannot donate electrons by means of resonance. They can only donate electrons inductively through the sigma bond. So that is why these guys are called weak, because they cannot donate electrons by means of resonance like the strongly activating groups and also the moderately activating groups. But we should note that these particular groups also direct the incoming electrophile to the ortho and also para positions. They are also called ortho-para directors because they direct the electrophile to the ortho position and also the para position. In this video, we've talked about the activating groups and we've talked about the three categories of activating groups. We have talked about the strongly activating groups. We have also talked about the moderately activating groups and also the weakly activating groups. Thank you for watching. If you're new to this channel, please subscribe to this channel.